Okay, so here we are with another question. Find right interval. I'll wait a few seconds before we get going. Oh man. Excuse me. I'm both tired, a little sick. I have a lot of things I should do or need to do. I don't really want to do any of those things. Just kind of just want to solve problems with the internet. Solve these Leetcode problems. Let's relax. Find right interval. All right, let's go. Let's see how this goes. Given an array of intervals, where intervals of i's start and end, and each start I is unique. The right interval for an interval I is interval j, such that start of j is greater than or equal to end of I, start of j is minimized. Return an array of right interval indices for each interval I. If no right interval exists for interval I, then put -1 at index I. Okay, I have no idea what they're talking about here. Not a single clue what they're describing. Probably have to look at some test cases to get a sense. Alright. There's only one interval in the collection, so output's -1. Okay. 3, 4, 2, 3, 1, 1, 2. -1, 0, 1. There is no right interval for 3, 4. The right interval for 2, 3 is 3, 4. Since the start of 3 is the smallest start that is greater than or equal to 3. Okay, so I think it's just the interval to the right. But it's also the interval with the smallest, which doesn't matter, right? Because they're unique. Do we just have to sort this on the x-coordinate? Yeah, I think we just sort this on the x-coordinate. And then just map the pairs back to their unsorted indices. You could alternatively like pair every interval with its original index, and then sort on the x-coordinate, the first coordinate, and then just return the return an array, a loop through build in a vector of integers of the indices from that sorted list. I think that's it. Right interval for 1, 2 is 2, 3, which is 1. 1, 4, 2, 3, 3, 4. So this should be, this doesn't have 1. There's no right interval for 1, 4, and 3, 4. Maybe I'm wrong. I'm very confused. Maybe I'm wrong about that. Maybe it's not as simple as just sorting it. I think I understand. I'm trying to understand. Struggling to understand. No right interval for 1, 4, 3, 4. The right interval for 2, 3 is 3, 4. Maybe maybe you do the same thing I just described, but instead of just dumping the third coordinates, I guess we'll call them a third coordinate into a vector of integers. For each interval, you're going to do a binary search for the first x coordinate that's further to the right of first x coordinate that's further to the right of the value that you're searching. So actually, you could dump these things into a set. Yeah, and use upper bound on the set, and the key for the set could just be like you create a pair out of the x coordinates and their indices, original indices, and then perform a search, binary search. I think you do this in n log n time. Pretty interesting question. How are we doing on time? 5 minutes? Okay. I think I got it. Excuse me. Yeah, I think I got it. Let's give it a shot. So we're going to use a set, the custom comparator function. So build set of starting indices, and their original position in the input vector. Hopefully that makes sense. So we use a custom comparator. I just have to check something on how it works with the comparators for sets. Oh man. Excuse me. Yeah. After the key, there's a comparator. Yeah, let's try this. So, what is the comparator though? Standard list key. This is its own class. That's the thing. It's not a function. It's a class. It's like a functor, which is a little unusual. So it'll be like an internal class. And it's going to be, I think we just need for this, yeah, you need this constant expression, this bool operator. Okay, and we're going to say left hand side, right hand side. We use t. It's not t, it's going to be vector. Well, we could use a pair, actually. I think I prefer a pair, yeah. And of ints. I actually think there's a version of this that I'm about to write this, but I think there's a version of this that already exists that's like stock. So it's not so difficult to do this, or it's not, you don't actually need to do what I'm about to do, but we're going to do the left hand side first, less than right hand side first. And now we can do standard set, or yeah, set of pairs, ints. Excuse me. And then this comparator. And we're going to just, I don't even know what to call this, we'll just call this S. And we're going to say for int I equals 0, I is less than intervals, dot size, plus I. We're going to create this make pair, so we're going to have s dot insert standard make pair, and the pair is going to be created using two integers. One of them is I, and the other one is intervals of I of 0. So access the first x coordinate. And then what we're going to do is we're going to loop over the intervals, search for the first element in the set that has a so j is greater than or equal to, yeah. Is greater. Lower the intervals and search for the first element in the set, the above set, has a starting point that is greater than or equal to the interval's second element, second coordinate, just call it coordinate. And retrieve from that pair, from the given pair, retrieve the index would be pair's second coordinate. It's a little confusing. I don't know, the English part of this is like kind of awful, so forgive me for that. Not really well explained. Not really well explained at all. Sorry about that. Alright, so for each interval, so the auto p in intervals, we're going to say int target is going to be p. Now it's actually the second coordinate, right? And we're going to do s dot upper bound, lower bound, upper bound. So the upper bound is going to give you the first element that's greater than or equal to, which I think is what we're looking for. Is that right? Upper bound, lower bound? Upper bound is, I want to say, greater than or equal to. Oh, no. Greater or equal is lower. Okay, so lower bound is greater than equal. We want actually lower. Wait, is that less than or greater than? Not, is greater than or greater or equal? Yeah. So lower bound is greater than equal. We want first element that's greater than or equal to this target. Just autocomplete's not giving me what I want. Alright, just want to see target. So we'll just say pointer. A few things to note. So each of these intervals, we grab the second coordinate and we say, okay, we want to know in our set that really it's sorted set, what's the first element that's greater than or equal to this target toward the right, and if that pointer is empty, so we say if not pointer, or it's really if pointer equals s dot end, then we ret dot push back -1. Otherwise, we ret dot push back pointer of the second value in that pair. Something like this. Nice. Compiler error. No matching member called to lower bound. No. There's in there a set. I think set has lower bound built in. Unfortunately, I'm not at a point yet where I can easily yeah, this should be it. Excuse me. Yeah, not really at a point yet where I can easily kind of manipulate this stuff. Why this? Int to I'm so confused. Oh, that's why. Oh, okay. I see. That's interesting. Well, I see. It'll just be a placeholder. The first element is the target. Yeah, that's kind of neat. I didn't really think about that. Key. That's why. Okay. Unusual. Object compare. Key. These are pairs. Which part is causing issues? Is it this one? And how are we doing on time? I think we're a little bit over time here, but this should be relatively quick. Almost 60 minutes. I see. Well, this is a pair, right? What's the issue? Exactly. Okay, that compiles. Why doesn't this work? We want to insert pairs. What is the issue? Candidate function not viable. No known conversion from const pair to const parent reference for second argument. Oh, what? Where did that come from? Bool operator implicitly declare. Oh, okay. Does this need to be public? Interesting. I mean, I don't know. Oh, okay. Interesting. I don't know if that's correct. It's supposed to be public. This comparator function. But maybe I'm missing something here where oh no, somehow I added an extra and ampersand. I don't know how I did that. How did that happen? Totally missed that. I think this is it. I think we're correct here. Could be wrong, but I don't, I think so. It's a pretty straightforward solution. Just basically sort, and take advantage of the sort. You can kind of make use of a set to kind of do things in a more simple way. I think we just go for it, quite frankly. Intervals of I always has at least 2. Start end length. If there's only 1, we already did that. What if it's empty? What happens if it's empty? I think we're fine if it's empty too. Oh, okay. Oh. Alright. Maybe I'll just try some like random test case, but this should be it. Yeah, 20 minutes. I mean, not great, but okay. 110, -1, 100, 1,000, 1,001, 1,000, 1,002, to 100,000, -1, 2, 3, 4, 10,000 to 5. I don't really know. Just try some random stuff. Alright, guess we go for it. I don't know. Hey, got there. Sweet. Not like the most efficient way to do this, but good enough. Good enough. I think relatively simple, the approach. I like it. I think it's okay. Not amazing, but not too bad either. Pretty relatively straightforward. Kind of ran into some hiccups here with the comparator where I had to look up, like, so if you're a custom comparator for your set, you would need a Boolean operator for the, what do you call it? what's that called? So you actually call not a Boolean operator, make the class callable, and then inputs to that call function. You want the left-hand side and the right-hand side, and this has got to be public, otherwise you won't be able to call. That's like a really, I don't say it makes your head spin a little bit, but like this isn't really a static function either. This is just a I guess it creates one object and then uses it and calls it. A little confusing, a little odd, a little bit strange, but I think it's okay. It's just kind of how the set was implemented. And then one issue here also is that because it's implemented this way, excuse me, if you want to use a key to search, if you want to use any of the search features within the set, you actually need to use a key, a full key, even though we're sorting things sort of only on, even though we might be sorting and searching on only one of the indices in the pair, we'll call it, or one of the parts of the pair, the object, you actually need a full pair object in order to, as a key, in order to search that set. So that's like another kind of nuanced thing where even though this dummy value is unused, you still need that pair, the full object to operate with. So that's pretty interesting too. Kind of wondering if this matters. I don't think it really matters. I think it's fine. So yeah, kind of a simple, really simple kind of thing, but obviously not as efficient as it could be, clearly. I mean, I think there might be a linear time algorithm, but and login is pretty good too. I mean, yeah, it doesn't need to be crazy efficient, crazy fast. I mean, if you can code it up pretty quickly, that's pretty good. So we're like a little over 20 minutes. Okay, I'll take it. Not bad. Pretty interesting question. Not bad. All right, let's end the video there. So thank you for watching. That was fun. If only we could be so lucky to get a question like that during an interview. That would be fantastic. Definitely a little bit of gymnastics there with the using the custom comparator for the set, and then also getting the right key. I think that kind of took some more time than it needed to. That's also something that would be pretty error prone during a whiteboard interview. So, all right, yeah, thank you.